Now the question is, Henry, in fact I want everyone to think about this. Look at those two equations and describe the lines. Just describe, and those of you who have already been talking about this, don't worry about it, but the rest of you who have been doing, yeah, yep, they are simultaneous, I guess. Well, yeah, okay. There's two of them, so we could do simultaneous equations, but we're not going to, because what would be the result? Because it equals 0. Not a good answer. Yes. I hate flies too. Now, but hate is a strong word. Now that the short answer is that these lines are parallel. The original question was find the shortest distance between these two lines. Now, really, if the lines weren't parallel, then eventually they would cross and the shortest distance between them would be 0. So it would be a ridiculous question. The fact that they are parallel, known by the 5x and the 6y, are in both equations. Correct. And therefore, yeah, that whole discussion of why people get not achieved in this topic is, it's now very clear. But the fact that they're parallel means the question should have read, find the distance between these lines. Because the shortest distance is the distance, and it's the same distance anywhere else we choose. So if you think about this, line 1, that imaginary line like that, there it is. We've got two parallel lines, and the question is find the distance between them. Yeah, that's bang on to scale. Yep, that's actually exactly how they are. And we need to find the distance of that perpendicular line segment which goes from here to here. So clearly we are going to need to know the equation of the perpendicular line. Trouble is, we don't know where it is because there are no points in this question. So what do? We choose a point ourselves because it doesn't matter. The distance from there to there is going to be the same as if the line was over there or there. This distance is going to be the same. Therefore, we just arbitrarily choose a point that's convenient. So I'm going to take this equation and I'm going to use x equals 0 and work out what the y value is that's on that line. If I put 0 in here, 6y take away 18, what must y be? Far too long, okay, bloody hell. 6y minus 18, that bit, equals 0. What must y be? 3, clearly, because that has to be 18 minus 18 is 0, so we need y equals 3. So our point 0, 3 is on, is there a slight echo in here? Oh no, it's Gilchrist. Sorry, what was it? I just chose 0. Because this line here, this line has an equation 5x plus 6y minus 18 equals 0, and I just need to know,
so we do that for both?
No, we don't, we just need one, because let's just say this point here is 0, 3, that's on that line. Now, can someone tell me what is the gradient of our top equation? What's the gradient of that line? Well, we have to be very careful about this because the gradient is the number in front of the x when it's written in the y equals mx plus c form, which it's not. Okay, so 5x plus 6 plus 6y, well, it's not that confusing. It's just that that is the general form and it's got nothing to do with the gradient. Well, let's put the 18 over here. That's known as change side, change sign. Damn it. Come on. Yeah, that very nice. The other Henry. And we put the minus 5x over here. And this is 6y. So what's 1y equal? Negative 5 over 6x plus 3. So it starts at 3. 0, 3 is a point. We knew that because we did that before. But the important thing is the gradient of our line is negative 5 over 6. So this line here, this line has a gradient of negative 5 over 6. What is the gradient of, go for sort of the dirty green colour, what is the gradient of that, which is at right angles? 6 over 5. So if the gradient of this is 6 over 5, and the point is 0, 3, we know that the point 0, 3 is on the line, then we can create the equation. We can work out the equation of the green line, which is y minus y1, y minus 3 equals gradient bracket x minus 0, which is that. So y equals 6 over 5x plus 3. Okay, so we haven't answered the question, but we've got the equation of the perpendicular line to both of those lines. So, just wondering what Gilchrist was doing with his right hand there. Looked a bit dodgy to me. But anyway, moving on. So, if we've got the equation of that line, and we know the point 0, 3 is there, we actually want the equation of this point here. Not the equation, we want the coordinate of that point there. Now, that equation we know, the green line equation we know, the blue line equation was the other equation in the question, and how do we find the point of intersection of two lines?
Same thing as we did before.
Simultaneous equations. Yeah. So therefore we use this equation, which we've constructed based on the fact that we wanted a perpendicular line, and we're going to solve that guy simultaneously with this one. So that one that I've just circled is that blue line, and that green line there is this one at the bottom of the board that we've just created. And if we solve those simultaneously on our calculator, because that's the safest way, then we're going to end up with the coordinates of this. So let's very quickly do that. In fact, if you've got a graphics calculator, and of course I have, but I'd say it's probably excellence, because there's so many steps. But if you now put into your calculator 5, 6, negative 70, 5, 6 and 79, here we go, I'll put it into here.
How many number of unknowns do we have? Is it 2?
Today, Mr. Windows XP, come on, wake up. There it is. Okay, so going back here, it was 5 x's, 6 y's, and 79. And the second equation, we have to be careful about this. The second equation is 6x minus 5y. In fact, I'll rearrange this. This one is 5y equals 6x plus 15. So it's 6x minus 5y equals negative 15. Just writing it in the format of the calculator. So the 6 minus 5. So there it is there. So we've got 6, negative 5, negative 15. Back in here. 6. Negative 5.
Let's solve it. Is it minus 185 over 11?
And if we get to there, putting it into our calculator, push the solve button. 5 and 9 is the answer. Yeah, whatever you did is not the same as me. I'm going with the 5 over 9.
Oh, I didn't do mine.
So it has to be rearranged so it's in the same one each time. So 5 over 9 is let's go back to our diagram, which is clearly not to scale, because if that's 0, 3, we've just discovered that this point here, according to our simultaneous equation, is 5, 9. Who cares? These are just two numbers. So the question didn't ask for the points, it asked for the distance. So I'm going to find the distance between 0, 3 and 5, 9. What's the up and across is, so 0, 3, 5, 9. Therefore, the distance is the square root of the x's squared, which is 25. Whoops. 5 5s are 25, and 6 6s are 36. So that's the difference between the y's and the difference between the x's, otherwise known as the rise over the run. Not yet, you can't. And add those together, you get 61. So the distance is the square root of 61, and I think you'll find on your calculator the square root of 61 is 7.81. And that is what it says on your calculator. Again, not that cunning, but masses of steps to get to the answer, like lots and lots and lots. Compared to achieved, it's probably about 5 steps as opposed to 1. But that's, you know, that's just how it is. It involved, in fact, if we count them up, it involved knowing what perpendicular was, knowing how to do the equation, knowing how to do simultaneous equations, and then distance. So there were 4 separate things there, which makes it 4 times as hard, or as long, 4 times as long as your average achieved question. So quite a performance, but you know, again, not impossible, and I'd like to think some of you could get there on the day, whatever day it is. So